The next topic in static electricity is going to look at the methods of charging and how do we actually transfer charge from one object to the other. There's really two main types that we're going to focus on. The first one is conduction, and that's when there's actually physical contact between objects. The common examples that you'll see with this is dealing with something called a pith ball. So this is a stand. We're just going to make this a little bit bigger so we can see it a little bit better, but this is a pith ball. And a pith ball is initially neutral. So we're going to have equal numbers of positive and negative charges on that object, right? And one way to think about this is how could we get this ball to become positively charged? How could we get this ball to become negatively charged? So the first way we're going to look at is if we wanted to get negatively charged, what we could do is we could bring a rod that's charged next to it. So typically how you'll do this is you'll have an acrylic rod or a plastic rod, and we'll rub it with something that's going to freely give away electrons, which would be like wool or something like that. And so if we have this as negative, then what's going to happen, right? Well, initially what's going to happen is all these electrons here are actually going to move to this side, which this object is still neutral. It has equal numbers of protons and electrons, but now we have an induction attraction, right? Not to be confused with this induction, but we have an induced attraction. So even though this object is neutral, it's still going to be attracted. It's actually going to swing over. It's going to tap the rod, right? And what that's going to allow, and so it's hard to show the movement of this, right, when we're drawing, but what that's going to allow, so if we actually draw it more like this now, is that's going to allow electrons to transfer over to here, right? And then, once we remove this rod, what we'll see as a result of that is we'll see a pith ball, which now has more electrons than it does protons, leaving it negatively charged. And it's actually going to be, let's draw it a little bit more like this, it's actually going to be repelled if we held that negatively charged. So these objects, this is getting pushed this way, there's some force there, right, and it's repelling due to it having additional charge. And so that's the process of when it physically touches, this is the conduction that takes place, okay? How could we get this pith ball to become positively charged? Well, instead of having a negatively charged rod, what if we had a positively charged rod, right? What would happen then if we brought a positive charge rod there? It would actually kind of work in reverse, right? The electrons would have all been attracted, and so we would have still got the pith ball and the rod coming together and touching, right? It naturally happens, even though this is still neutral. Then what would happen is we'd see electrons move the other way. They would go onto the rod, they're attracted to that, and that would leave this pith ball positively charged then here. So it still has negatives, but there's more positives than negatives. And again, if this is positively charged still here, it would still repel, right? So those are two instances of how could we get the pith ball to be negative or positive, okay? The other way of charging is a little bit more complicated, but it's through what's called induction. And that's where there's actually no physical contact between objects. A charge can be induced, but what must occur is that this must actually happen in a conductor. The reason for that is because we actually need a flow of electrons for this to occur. And let's look at a few examples of that. Okay, so one of the examples that we're going to look at is how can we charge something through induction, right, without actually physically touching it. And so a big important thing with this is something called ground, right? So in our picture here, this is representing of the Earth. So anything down here is the Earth. And Earth is very unique in that it has so many protons and electrons associated with it. The Earth is free to give and take electrons, right? It can give away as many as we want. It can take as many as we want because there's so many there, right? And so what we can look at is the process of connecting something to ground. So if we were to connect something to ground, so this is now grounded, and if it is connected to ground, it has the ability to allow electrons to either move to either way, right? So the Earth again can give or take electrons. So this circumstance, let's think about what's going to happen. Really, even before we connect it to ground, what's going to happen, right? We bring a neutral sphere. It is a conductor, which means electrons can flow around the surface, right? And we bring a negatively charged rod next to it. What's going to happen then is all these electrons are going to be repelled from this rod. So the electrons are all going to move onto this side. So we're going to lose these electrons from this side, and they're going to move to the other side, okay? Again, there is some attraction then between the rod and the sphere, right? If the sphere was small and free to move, you could have contact or conduction, but because it's fixed right now, it's not going to be free to move, right? What we can then do is if we connected it to ground, well, now those electrons have a pathway to get even farther away from this negatively charged rod, which they want to do. So those electrons are going to move in this direction. They're going to move towards ground. And in moving towards ground, because the Earth can take so many electrons, they're actually going to lose some of the electrons from the sphere. All right? Now, we got to be very specific in terms of how we take things away or the next steps, right? One thing is, if we were to get rid of the rod or remove the rod, take it far away, what would the electrons do? Well, this sphere is now positively charged. There's free electrons in the Earth, and it's still grounded. Those electrons are actually going to move back into the sphere because it wants to neutralize. So what you have to do is, in a very specific order, again, we'll just do quick negatives there, right, is what we'd want to do first is we'd want to remove the ground. And in removing the ground, we eliminate a pathway for the electrons to move between the sphere and the Earth. Once we remove the ground, what we can do is we can then take away our rod, and what we're left with is something that has a negative charge left on the sphere. All right? So think about how could we get the sphere to be positively charged, right? If a sphere is initially charged, could we get it to neutralize? So all these things are ways that we can charge something through induction by causing electrons to move through a conductor.